Hello, good denizens of the internet. My name is Dr. James Wotton and I work at the University of Basel. This is my new game, Decodoku. I don't usually develop games, I usually develop quantum computers, which will be a new kind of computer that can do things much faster than normal computers, but can also do things that normal computers can do, like play Mario Kart and stuff, though that's not really the application that we're aiming for. One reason we don't have quantum computers at the moment is because they are very susceptible to noise, so we have to work out freakishly awesome ways to deal with that noise. And that's what I'm here to get you to help us with. I've created this app which brings quantum error correction to you and lets you figure out the puzzles, because quantum error correction is all about puzzles. We have traces left by errors, clues as to what errors happened. We need to take those clues, work out what happened, and correct it. So in this particular error correcting code that you see in the game, what errors do is they create small groups of numbers that add up to a multiple of 10. So there must have been an error here which created these two 5s, they add up to 10. There would have been an error here that created that 3 and a 7, and there'll be more complicated errors here that created this 6, 7, 1 and 6, which adds up to 20. So these are the errors, we can quite easily see them, and so we can use the app. This is the web version. The controls on the Android and iOS versions are much better. We can drag these numbers around, they'll add up. So you can see they added up there, and they added up such that multiples of 10 disappeared. So when we bring the 6 and the 4 together, they disappear, 7 and a 3 disappear, 4 and a 6 disappear. Over time, more errors come. So we see here that this 5 that was here before has now been split by an error into a 2 and a 3. And then we've got another group, which is this 8 and a 2, and so on. We just have to keep on keeping track of where the errors are, what the groups are, and we can get rid of them. Now you may have noticed earlier that I clicked on a number and it changed colour. So this we can do to keep track of what the groups are. So we can say, oh, that looks like a group, this looks like another group, so we'll make it a different colour, this looks like another group, and so on. We can go through trying to keep track of the groups. So what group does that belong to? It's not quite clear. Let's move on to this one. Oh, that needs to be green. So these make a group, so probably this 5 goes with that 5 down there, and so on. We can start clearing them up, and eventually more numbers will come, and the colours get inherited. So this is how it goes on, and basically you need to get a high score. So every move you make adds to your score, and you need to make as many moves as possible. So you need to last as long as possible before the errors get so bad that they mess you up. So I should note actually that, say we were to add this 6 and a 5, that would come to something bigger than 10, it will come to 11. So if we actually did it, the 10 would disappear and we'd just get the 1. So the way that a game ends is when you get a group that's so big that it goes across the grid, either top to bottom or left to right. And the way we can see these more easily is if we use a training game, then each group is in its own colour. And then if we play it in a training game, then we'll see how the groups get bigger, because we can't actually correct as many errors as happen every move. Every set of moves before a new set of errors comes. So over time they will build up, we will get quite big groups. At the moment that doesn't seem to be happening, we seem to be doing quite well, which is not so great, given that I want to show you what happens when we do badly. But so after this lot I'm going to start making some errors. Let's see how, say I think this 6 goes with that 2 there. Well, this means that their groups combine. Let's say I think that 8 goes with that 8. Well, now their groups have combined. Oh, well, what should I do with this 4? I can combine it with that. Now their groups have combined. This has got now a quite big group, and a new set of errors has taken it so that we've got something on the bottom and on the top. So game over. We had a score now of 41. As it was a training game, it doesn't count towards our high score though. We'd have to play it on a proper game for that. The Gamefly lambda is exactly the same, except you don't get as much information. So this lambda is a 5, but everything else here is either a 1, 2, 3, 4, 6, 7 or 8, you just don't know which. So this is probably something like an 8 and a 2 or a 6 and a 4, and of course they add up to 10 and disappear. So that's it. Play this game, work out methods to get high scores, tell us about them, look at the links below, and you will help us do the science of error correction, quantum error correction, and help us build a quantum computer. Thanks.